Welcome to the video series on understanding genetic tools. This is aiming to explore how genetic tools can help support, make more informed livestock purchasing and breeding decisions. This video series is aimed at livestock advisors, commercial producers, service providers, agents, and seed stock breeders, anyone that wants to understand genetic selection tools better. It's also focusing on both beef and I'm Marnie Hodge, one of the development officers at Sheep Genetics, and I'll be joined by Kate Rummery, another development officer at Sheep Genetics, as part of this series. Within the overall series of understanding genetic tools, we'll be delivering 4 individual videos. The first will be looking at the impact of genetics, so the why around genetic selection. The second will be around interpreting breeding values, so understanding how to read a breeding value, what information is incorporated and accounted for in a breeding value. The third video will be around Australian genetic evaluations and tools. So what have you got currently available to you to help make your genetic selection decisions? And the fourth and final video will be around how to set a breeding objective for direct and non-direct profit driving traits, and also to make sure that it's hitting market specifications. So let's begin at looking about why genetics matters within a livestock business. We know that how an animal looks or performs is influenced by both genetic and non-genetic factors. Things like nutrition, animal health, management, and season all have an influence on how an animal performs today. However, genetic has an influence on how an animal will perform today and into the future. Genetic improvement is permanent and cumulative. Within each new generation, you're able to select better animals to improve the genetic merit of your herd or flock into the next generation and the next and the next. So you can continue to build on that improvement over time. So what does that cumulative improvement actually deliver to you or your clients? Through genetic selection, you can improve profit and production. This looks like increased profit and production per individual animal. So selecting for traits like growth, fleece weights, and reproduction ultimately leads to more kilos sold per animal. You can also increase your profit and production per hectare. So improving a genetic selection for growth, survival, and reproduction traits ultimately leads to more kilograms produced per hectare. You can also utilize genetic selection tools to help hit a paid market premium, which could be a trait like marbling or eating quality, fiber diameter, or improving your breech wrinkle over time, which ultimately leads to more dollars received per kilogram of livestock produce. And as I keep mentioning, genetics is permanent and cumulative. It's one of the only on-farm levers that you as a advisor or RAM purchaser can actually use to increase every generation over time. So if we have a look at the sustained impact of genetic selection, what does that actually look like? We've got a graph here from the Angus evaluation for 400-day weights over time. So this is looking at the last 20 years from calving years 2006 to 2025, and how the breeding value or the genetic merit on average for Angus for 400-day weight has changed over time. Over the last 20 years, Angus on average have been able to increase their genetic merit by about 30 kilograms over time for 400-day weight. So this ultimately has meant that Angus cattle on farm are reaching a heavier weight at 400 days of age. If we look at and change tact to the merino industry, we can see that change in merinos is also very clearly visible when we actually look at how that animal has looked and changed over time. So the merino today looks a little different, and this is obviously a dramatic photo of a traditional merino. But the merino today looks quite different to how an older merino looks, and that's as a result of deliberate selection for key traits that drive profit, as well as non-profit driving traits over time. If we have a look at how the data in Merino Select has actually changed over time as well, That actually allows us to quantify these changes rather than just relying on what we can see. And we'll get into this a little bit further. But what we're looking at here, and there's a few traits displayed, is the change in the average genetic merit for a few key traits in the Merino Select analysis. So we have the yellow line here, which is yearling clean fleece weight, which has increased quite dramatically in the last 10 years. So for yearling clean fleece weight, for example, we've been able to improve that through genetic selection. This improvement's been made simultaneously whilst also holding fibre diameter. So we're improving yearling clean fleece weight and holding fibre diameter, which are antagonistic traits. We've also been able to improve weaning rates per ewe joint, all the while being able to also make improvements for breech wrinkle as well over time. So we know that genetic change is possible. That's very reflective in both sheep and beef evaluations. But what controls how quickly we can actually make these changes? We know how an animal performs or its phenotype is influenced by both genetic as well as non-genetic or environmental factors. So selection based purely on environment or actual raw performance can sometimes be misleading. We know that what an animal looks like or how it performs can be influenced by a range of different things. How much that animal has eaten or its nutritional status, how old that animal is, whether it was born a single or a twin, and also raised a single or a twin, how old the dam was, and also that animal's health status. But ultimately, as well, what that animal's genetic merit is. So we can make genetic gain and increase the rate of genetic gain to produce more profitable, productive, and resilient livestock through a few different ways. The first is obviously to select animals with better genetics. So first, buy bulls or rams with breeding values, but then also track your average performance over time. Make sure you set a breeding objective and use that breeding objective to help you inform your purchasing decisions. So to continuously purchase and use bulls or rams with better genetics than what you did the year before. The second way that you can increase your rate of genetic gain is obviously to use more of the higher genetic merit animals. So join more females to your best sires. Retain replacements through your best genetic merit animals. Another way that you can increase your rate of genetic gain is also to shorten your generation interval. So this assumes that the younger sires have a higher genetic merit, because if you're selectively breeding, obviously the animals that you aim to produce should be better. Now, we know that some traits are connected. So selecting for one trait will have an influence on others, which we'll talk about in a little bit of time. And we also know that particular traits, you can improve the rate of gain compared to others. So let's talk about that. So how much of the performance is actually influenced by genes is called the heritability of a trait. So some traits have a high or moderate heritability and some traits have a low heritability. The higher the heritability, the higher the potential rate of genetic improvement you can have in a quicker time period. So something like growth traits have a medium heritability, which means that of the performance, a medium or moderate part of that is influenced by genetics. So something that has a medium heritability, you can make some quite substantial gains quite quickly over time. Something like fertility, though, for example, is what's referred to as a lowly heritable trait. That means that how an animal performs for reproduction has more of an influence of non-genetic factors compared to genetic factors. You can still improve lowly heritable traits like fertility and reproduction over time. It just takes a little bit longer. I also mentioned some traits are genetically correlated or have an influence on others. So this is a really good thing when traits are favorably correlated. So if you think about in sheep, for example, live weight and fleece weight, that has a favorable correlation, which means that if you were to select for live weight, your fleece weight will increase naturally or organically. Other traits have unfavorable genetic correlations. which means that if you were to select for one particular trait, it would have an unfavorable impact on another trait. So in sheep, something like fleece weight and fiber diameter is a great example of an unfavorable genetic correlation. So this would mean that if you were to select animals to improve your fleece weight genetic merit over time, that would have an unfavorable correlation on your fiber diameter. So it's really important to think about these genetic correlations when you're making your selection decisions, and we'll talk more about this in the breeding objective section. If you need any more information about anything that was discussed in this first part of the video series, please contact Sheep Genetics.